Well, hey everybody, how you doing? So now we're going to actually get to begin real trigonometry. All we've done so far is just focus on how we measure angles, and we learned all about degrees, DMS and DD form, and we learned about now the radian measure and why it's important. But now we're going to delve, when we get into section 1.3 and 1.4, we're going to delve into really what trigonometry is. Trigonometry is a Greek word. It means the study of triangles. So the reason why we even have trigonometry is to expand our notion of solving triangles. So you have to think back to geometry. Back in geometry, you all learned how to find a missing side and a missing angle of a right triangle. And that was great. You all learned Pythagorean theorem, and you learned that 3 angles of a triangle add up to 180. But then there came a point in time when you were given information and you didn't have enough. For example, they only gave you 1 angle and you couldn't find the other 2. Or they gave you 1 side of the right triangle and you couldn't find the other 2 because you didn't have enough information to use Pythagorean theorem. Or you didn't have enough information to add up the angles that make 180. That's what the need for trigonometry is. So trigonometry, the definition is a study of triangles. And we start out with the right triangle. So what we want to do today in this lecture is teach you the new trig words, the words that relate to trigonometry. And yes, that means you have some memorizing to do because you're going to hear these words throughout the whole semester. So it's very important when I say memorize, I mean it. You need to memorize. Okay, so we're going to start with drawing an angle in standard position. So here I have my XY coordinate. To draw an angle in standard position, remind me again, where does the vertex point go? Good, the origin. Where does the initial ray always go? Good, the positive x-axis. And what happens here is we could draw the terminal ray in any one of the 4 quadrants. So let's draw the terminal ray in quadrant 1. So right here is our angle. And I don't know its exact measurement. So remember, what variable are we going to use to denote the angle we don't know? We're going to use theta. Remember, theta is the Greek letter we're going to use to denote our angle measurement if we don't know exactly what it is. If you look at this picture, you can take this picture and draw a right triangle. Now, to be a right triangle, you have to have a right angle, which is how many degrees? Good, it's 90 degrees. And to have a 90-degree angle, that means 2 sides of the triangle have to be perpendicular to each other. Remember, me to the t? So what happens here is we have to draw a perpendicular line to the initial ray. So to make this become a right triangle, we are going to drop a perpendicular line from the terminal ray to the initial ray. I'm going to do that in green. And I'm going to put my marking to show that's 90 degrees. We have now made a triangle in quadrant 1. And we know that the length from here to here is on the x-axis, so we would denote that with the letter x. We know the length here to here is up and down, so that would be whatever the y-axis is. And this piece right here we know is the diagonal of the right triangle. Now back in geometry class, what do we call the diagonal? Started with the letter H. Good. You called this in geometry the hypotenuse. And if you remember, what letter in Pythagorean theorem do we use to represent the hypotenuse? Good, it was C. So if you remember the Pythagorean theorem, I'm just going to write it under here. Okay, Pythagoras was a mathematician who found out there's always a relationship between the 2 sides, which are called the legs, and the hypotenuse of the right triangle. Do you remember how to write the Pythagorean theorem? Good. It's a squared plus b squared equals c squared. But we're not going to use a and b because the length of this side is represented with x. So we're going to write x squared. And the length of this side is going up and down, so we're going to represent that with y. That's y squared. We're also not going to use c because what I want you to know is this length, the diagonal, is also the radius of a unit circle. So technically speaking, if I drew a circle in this picture, remember we were talking about unit circles the other day? From here, the origin, to here, that length would be the radius. So they're going to denote the diagonal of the right triangle, which we called in geometry the hypotenuse. We're going to call that the radius squared. So what you're used to seeing, a squared plus b squared equals c squared, Pythagorean theorem, in trig, we're going to write it as x squared plus y squared equals r squared. Now, once we draw this right triangle, trigonometry, the definition is, it's the study of the relationship of one of the acute angles with two sides of the right triangle. That's your definition. Trigonometry is the study of the relationship of one acute angle with two sides of the right triangle. So in this picture, that's 90 degrees. Is that acute? No, it's not. In this picture, both of these angles are complementary. They would add to 90 degrees. So both of them are acute. When they talk about the relationship of the acute angle, they're talking about the angle here by the vertex. So trigonometry is the study of this acute angle with two of these sides of the right triangle. Now we have this one labeled x, we have this one labeled y, and now we know we're going to label this one r. So we only need two of these sides. And trig has 6 definitions. There are 6 trig words. They are sine, cosine, tangent, cosecant, secant, and cotangent. So those are your 6 trig words. Sine, cosine, tangent, cosecant, secant, and cotangent. And guys, I'm about to give you definitions. Now, definitions are things you cannot question. You have to accept them as true. So, for example, in real life, if I said I had a pet at home, and that pet has 4 legs, wags its tail, and go woof woof, what would you call it? That's right, you would call it a dog. Why do we call it a dog? Because in our world, that's what somebody defined that animal to be. If you have a pet at home that has 4 legs, wags its tail, but goes meow meow, do we call it a dog? No, we call it a cat. It's a definition. We accept it to be true. So I'm about to give you the 6 trig word definitions. Don't question them. You have to accept them as true, and you have to memorize them. Okay, here they are. The sine of theta. Now I know what you're saying. It's written as S-I-N, sin. When we use them in writing, we abbreviate them. The abbreviation for sine, S-I-N-E, is S-I-N. It is not trig if you just write on your paper S-I-N. So for example, if I just wrote on my paper S-I-N, that's not trigonometry. That's the word sin. The reason why I know this is a trig word is because behind the word sine is theta. The trig words will always be accompanied with an angle measurement. So this theta's got to be there. So if I just write on the paper S-I-N, it's not trig. I have to write S-I-N with an angle behind it, whether it's an actual number, 30 degrees, 45 degrees, 60 degrees, or I put theta. The sine of theta equals y over r. So the definition of sine is it's the relationship between this acute angle and the side that's y and the side that's the r. Don't question it. That's the definition. You got to accept it. Now you have to memorize that. We're going to use that the whole semester. Sine theta is y over r. Cosine theta is x over r. Tangent theta is y over x. These are your 3 basic trig functions. If you look at your calculator, every single scientific calculator has a button for sine, cosine, and tangent. And we'll learn about those buttons in a later video. But right now you have to understand why they are defined the way they are. Trig is a relationship between an acute angle and 2 sides of the right triangle. Now, each of these guys have a buddy with them. Each of these trig functions have a reciprocal function. Let's go back to elementary school. What does the word reciprocal mean? Well, if I have the fraction 1/2, what is the reciprocal of 1/2? Well, you would flip it. So the reciprocal of 1/2 is 2 over 1. Each of these trig functions is a fraction. y over r, x over r, y over x. So you have to agree with me, all three of those fractions can be flipped. So when I flip y over r and I write over y, I get a new definition. And the definition of the relationship of r over y is cosecant theta. So look at me. If you know the definition of sine is y over r, then all you got to do is make the connection. Sine and cosecant are reciprocals. So if this is y over r, cosecant is r over y. Cosine is reciprocal with secant. So if cosine's x over r, secant is r over x. And tangent's reciprocal is cotangent. So if tangent's y over x, cotangent is x over y. So again, you see these 6 trig definitions? You have to memorize them. Really, you only have to memorize 3 of them, sine, cosine, and tangent, and then know which function is their reciprocal, who they buddy up with. Now, what we're going to do is learn how to write this. Okay, so we have some examples in our notes. I'm going to do example 1B and 1C to start you off. So the directions say, given this ordered pair, draw the angle in standard position and define the 6 trig functions. So let's do step 1 that we've already learned. Draw the angle in standard position. What does that mean? It means, where do we place our vertex point? Good, at the origin. Where do we place our initial ray? Good, positive x-axis. Here's the difference. We're not given an angle. So if we're not given an angle, we don't know how many degrees our angle is going to be to draw. What they're giving us here is an ordered pair. Well, think about your skills of graphing. What do you do with an ordered pair? You plot it. So let's plot -6, -8. What quadrant is -6, -8 in? Good, it's in the third. So you'd go -6, and you'd go down to -8, and there would be that ordered pair. That's where the terminal ray is going to go. So here's our angle in standard position. We don't know its exact measurement, but we know it's bigger than 180 and less than 270. You all with me so far? Because it's in quadrant 3. Now, to define the 6 trig functions, to give their definitions, we have to draw a right triangle. The way we drew the triangle in quadrant 1 is the way we're going to do it for all the quadrants. So if I continue up here, this is the triangle drawn in quadrant 1. If I had my terminal ray go in quadrant 2, the rule is to draw the triangle, you drop a perpendicular down. So from quadrant 2, if here's the terminal ray, the perpendicular would come down, and there would be my right triangle, and there would be my angle theta. If my terminal ray is in quadrant 3, again, the definition is we're going to draw a perpendicular. See how this perpendicular touches the x-axis? See how this perpendicular touches the x-axis? The same thing here. To draw a right triangle in quadrant 3, you're going to draw the perpendicular to the x-axis. So there would be your 90-degree angles. This would be your angle theta. You are never going to make a right triangle by drawing a perpendicular to the y-axis. It's always to the x-axis. If over here I was drawing my triangle in quadrant 4, if here was my terminal ray in quadrant 4, I would draw my perpendicular still to the x-axis. There would be my 90 degrees. There would be my theta. So when you're asked to draw a right triangle, it's always going to be drawn by drawing the perpendicular to which axis? Good, the x. So here is my terminal ray. I'm in quadrant 3. I want to draw my perpendicular to the x-axis. Everybody agree? This is going to be my angle theta. Not the whole angle, just what's inside the right triangle. Now, to do trig, I need to know the sides of the right triangle. Well, we already know 2 sides because if you know this is an ordered pair. The -6 stands for x. The -8 stands for y. So if I look at my picture, when I went back 6, that's my x value. When I went down 8, that's my y value. So now that we know this side x and this side y, we need the radius or the diagonal. we're using Pythagorean theorem, but instead of writing a squared plus b squared equals c squared, we're going to write x squared plus y squared equals r squared. So I'm going to do that up here. So you use x squared plus y squared equals r squared. X is negative 6. Y is negative 8. According to order of operations, we square first. Negative 6 squared is 36. Negative 8 squared is 64. We add them up. We get 100 equals r squared. How do we get rid of square, people? Good. We square root. What is the square root of 100? It's plus or minus 10. But if you remember, when you use Pythagorean theorem, you don't do plus or minus because a radius is a length, and a length's got to be positive. So we just put positive 10. So when you're doing or drawing a right triangle and you're finding the length of the radius will always be positive. The x or y does not have to be positive because it talks about which way you moved. And because I went to the left and down, that's why my x is negative and my y is negative. Now, once we have our triangle filled in, we're able to define the 6 words based on these definitions. What I suggest you do, what always helped me, is to label. This is my x value, this is my y value, this is my r value. Make sense? X goes right and left, y goes up and down, the diagonal is the radius. So now all this is memorizing. Sine theta is y over r. Our y value is negative 8, our r value is 10. Cosine theta is x over r. X is negative 6, our r value is 10. Tangent is y over x. Y is negative 8, x is negative 6. Now to do the other 3 functions, trig functions, they are reciprocals. What does the reciprocal mean to do? Flip the fraction. So guys, all you got to know is who matches with who. Cosecant always matches with sine. So if sine is y over r, cosecant is r over y. Secant always matches with cosine. So if cosine is x over r, secant is r over x. Cotangent is the reciprocal of tangent. So if tangent is y over x, cotangent is x over y. So the moral of the story is you don't have a choice. You have to memorize these definitions. We're going to use them the whole semester. Now the problem with this is these answers are all fractions. What have you learned in elementary school about fractions? That's right, they got to be reduced. So we're going to reduce them all. So this reduces to negative 4/5. This reduces to negative 3/5. What's a negative divided by a negative? It's a positive, so this would be positive 4/3. This is going to be negative 5/4, but can you leave a negative in the denominator? Absolutely not. A negative always floats to the top. So this is negative 5/4. This is negative 5/3. And this is going to be, again, positive 3/4. Trig is a relationship between an acute angle and 2 sides of a right triangle. That's all we're learning, is that's what trig is. Okay, is everybody good so far? All righty. Let's move on to 1C. All right, again, the definitions say, given this information, draw me an angle in standard position, and then define the 6 trig function values. So again, I'm giving you an ordered pair. So we know negative 1 is x, square root of 3 is y. All right, what quadrant is that point going to be in? Well, if we plot it, the x is negative 1, so we're going to the left negative 1. The y value is positive. Who cares that it's an irrational number, a square root of 3? It just means we're going up. Okay, just to get used to this, square root of 3 is roughly 1.7, $1.70, just so you know. So if you were using graph paper, you would plot this point between y is 1 and y is 2. So from that point, we're supposed to draw an angle in standard position. So we put our vertex, we put our initial ray. Here's where our terminal ray is going to be. Anytime they talk about the trig definitions, the trig functions, you must have what shape? A right triangle. So we're in quadrant 2. How do we draw the right triangle? That's right, we have to draw a perpendicular line, always going to what axis? The x. So I'm going to drop my perpendicular line again here. I'm going to put the 90-degree angle, I put my theta for my acute angle. My angle theta is always the one next to the vertex point. So to do trig, to define the 6 trig functions, I need numbers in my triangle. Well, I know what x is. X was -1. I know y. Y was the square root of 3. So to find the length of the hypotenuse, which we're now calling the radius, we're going to do Pythagorean theorem. But instead of writing a squared plus b squared equals c squared, we're going to do it as x squared plus y squared equals r squared. So our x is -1. Our y is square root of 3 equals r. -1 squared is 1. Square root of 3 squared is just 3, because the square root of 3 times the square root of 3 is square root of 9, which is just 3. 1 plus 3 is 4. And to get rid of the square, we do the square root. And what is the square root of 4, everybody? 2. Technically, it's both positive and -2, but because we're talking about the length of the radius, it's a distance. Distance has got to be positive. Everybody's good? Awesome. Once you get your picture drawn, all you got to do to define the 6 trig functions is know your definitions. So you need to practice saying them. The sine of theta is y over r. Now, before I actually do it, I'm going to label. This is my x, this is my y, this is my r. It just helps me. So if I know my definition, sine is y over r. That's square root of 3 over 2. Cosine is x over r. That's -1 over 2. Tangent theta is y over x. That's square root of 3 over -1. Now we're going to talk about the reciprocals. Cosecant is the reciprocal of sine. So if sine is y over r, this is going to be r over y. So this is 2 over square root of 3. Secant is the reciprocal of cosine. If this is x over r, this is going to be r over x. Cotangent is the reciprocal of tangent. If tangent's y over x, this is going to be x over y. Everybody good? There's no work here, people. That's memorizing. I can't fix that. You have to do that for me. You have to commit yourself to memorizing these 6 definitions. Now, the problem is not all of these fractions are acceptable. Fractions have to be written correctly. Yes, they have to be in lowest terms. Yes, you can't leave a negative in the denominator. It's got to float to the top. But more importantly, fractions always have to have a denominator that's a positive whole number. This one is acceptable. This is acceptable. This is not. If the negative floats to the top, this would be negative square root of 3 over 1. Do you need a denominator of 1? No, you do not. So this is negative square root of 3. This one is unacceptable. Now you're going to say to me, why, Ms. Black? There's no negative. Because the denominator is not a whole number. The square root of 3, as I said a minute ago, is the decimal value $1.70. If I walked into class today and say, hey, we're going to divide into groups. Everybody go, divide into square root of 3 groups. Does that make any sense? No. If I walked into class and said divide into 3 groups, that makes sense. So that's why when you give an answer that's a fraction, the denominator must always be a whole number. So now we got to review some algebra skills. How do you change a square root of 3 into a whole number? Well, you have to use a skill from 3rd grade math. I know, I said it, 3rd grade math. The skill you have to use is making an equivalent fraction. All right, what does that mean, an equivalent fraction? Suppose I have the fraction 1/2. So let me just erase for a minute here. Suppose I have the fraction 1/2. And I ask you, give me another fraction that's equivalent to that. Well, you can give me 2/4. You can give me 3/6. You can give me 4/8. And this could go on and on forever. In your head, what operation are you doing to make an equivalent fraction? You're multiplying. You're saying to make 1/2 become 2/4, I multiply the numerator by 2 and the denominator by 2. To make 1/2 become 3/6, I multiply the numerator by 3, the denominator by 3. Even though these don't look the same, A half and 4/8 don't look the same. We know they have the same value. They mean the same number. Well, the same thing's here. This fraction, 2 over square root of 3, is unacceptable. The denominator of a fraction must always be a whole number. So we're going to make an equivalent fraction. We're going to multiply. Now the question is, what do you multiply by to make a square root of 3 a whole number? Okay? Well, if it's a square root, you can only multiply it to a square root. The only way to make square root of 3 a whole number is to multiply it by itself, square root of 3. You just did that up here a minute ago. What's square root of 3 times square root of 3? Well, that's square root of 9. But what is the square root of 9? 3. Anytime you multiply a root by itself, you get out that whole number. So if I multiply by square root of 3 in the denominator, I got to balance by multiplying in the numerator. So now 2 times square root of 3 is 2 square roots of 3. Square root of 3 times square root of 3 is square root of 9, but that's just a 3. And that is the acceptable fraction. If you remember in algebra, that was called rationalizing the denominator. It meant get the radical out of there. It's not anything crazy, guys. It's doing third grade math, making equivalent fractions. All right, can I accept the fraction 2 over negative 1? No, I'll float the negative to the top. I don't leave a denominator of 1, so this just becomes negative 2. Can I accept the fraction negative 1 over square root of 3? No, because there's a radical in the denominator, so I'm going to rationalize. I'm going to multiply by square root of 3. I'm going to multiply by square root of 3. That gives me negative 1 square root of 3 over 3. Do I need the negative 1 in front? Well, I need the negative, but I don't need the 1. So this is going to be written negative square root of 3 over 3. The hardest part here is not the trig. Memorizing the definitions is not hard. The hardest part here is understanding all these fractional values have to be simplified correctly. Now, let me talk a minute. You see over here how we had to do Pythagorean theorem to find the length of the diagonal, the radius? In your notes, I have a little box that says Pythagorean triplets, or triples. So in your notes, if you look, there is a box that has a hint that says Pythagorean triples, or triplets. And in that box is written 3, 4, 5, 6, 8, 10, 5, 12, 13, 8, 15, 17, 7, 24, 25. What that is a little helpful hint. And let me explain to you. If you look here, this side was negative 6, this side was negative 8. The radius came out 10. Well, that's one of the triples. If the leg is 6 and 8, it doesn't matter if it's positive or negative. If the leg is 6 and 8, every time you do Pythagorean theorem, the radius is going to come out 10. So you wouldn't even have to do that work for me. Because if you know these, have these memorized, I would know, oh, the leg was 6 and 8, their radius should be 10. So if I had a right triangle drawn, and I knew the leg was 8 and 15, what would the radius have to be? 17. Now over here in this picture, we didn't have a triple. It's a 1 and a square root of 3. There is no 1 and square root of 3 on this list, therefore we have to do Pythagorean theorem. So that's just a helpful hint. If you're good at memorizing facts, I use that all the time. Because you're going to see these triples come up all semester. And I'm all about saving time. I don't need you to do Pythagorean theorem every time. If you know the leg is 3 and 4, you know the hypotenuse is going to be 5. All right. Now, we have one more example I want to look in these notes. And that's example 2. Because the problem now is, not every time I ask you to define the 6 trig functions, am I always going to give you the same information. Right here I gave you ordered pairs. And from there you plotted them and drew the triangle. Let's go to example 2, please. Example 2 gives you 2x plus y equals 0, x is greater than or equals 0. And it says, draw the triangle in standard position. Well, standard position. Vertex point is at the origin. Initial ray is on the positive x-axis. Now I got to draw the terminal ray. Well, this is very different. I'm not given an ordered pair anymore. This thing right here is a linear equation. Okay, so I'm going to do some erasing so we can do some work here. Okay. In trigonometry, I can't reiterate enough how many times something's going to come up from your past in math and bite you in the butt. I can't reteach you everything, guys. All I can do is expose to you. You're supposed to know if I have 2x plus y equals 0, that is an equation because it has an equal symbol. And you should know by now it's a linear equation because x and y are to the first power. And the word linear is Latin for the word line, which means you should know from Algebra 1, if I ask you to draw a picture of this equation, it should make a line. Now there's 3 types of lines. There's horizontal, vertical, diagonal. You should know by looking at this equation, because it has an x and a y, it's going to touch both the x-axis and the y-axis, which means it's got to be a diagonal line. And you should know to graph a diagonal line, the most quickest and efficient way is you need to put it in slope-intercept form. What is slope-intercept form? Y equals mx plus b. So you should remember from Algebra 1, to graph a diagonal line, I have to have y isolated. So to get y by itself, I'd have to move the 2x over here, which is by subtraction. So this would be y equals negative 2x plus 0. That is in slope-intercept form. Do you remember why we do that? We do that because the 2 numbers on the right side are the information we need to go to the graph paper. This negative 2 is in the spot for m. This 0 is in the spot for b. Now you got to know what these words mean. These are abbreviations. M stands for the word slope. If the slope is negative 2, slope is movement. Slope tells you how the line moves up and down and left and right. You would probably remember the catchphrase, slope is rise over run, which means slope has to be written as a fraction. So to write this as a fraction, we'll put it over 1. So now we know we're rising negative 2 spots and we're running 1. Well, you can't move up or down or left or right till you have a place to start. That's what the B is. The B stands for the word y-intercept. Intercept means to touch. In football, if you intercept the pass, you get the football, you touch it. A y-intercept is where you're going to touch the y-axis. So this is an actual point. So your y-intercept is at 0, 0, because your y value is 0. And if you're going to touch the y-axis, that means your x value has got to be 0. So here's the problem. It's not the trig. It's you remembering all this information. Oh, they're giving me an equation of a line. It's linear. X and y are to the first power. Linear means it should be a picture of a line. If it has an x and a y, it's diagonal. I have to have it in slope-intercept form. I need the slope and I need the y-intercept. I start with the y-intercept. I plot 0, 0. This line is going to rise negative 2. Rising either goes up or down. If the rise is negative, we're going down. I'm going down 2. I'm running 1. Because that 1 is positive, I'm going to run to the right 1. And that's where that point would be. And then I could draw that diagonal line. Now, are you with me? I know a lot of review, but you're supposed to know all that. You've mastered all that. You've seen it in Algebra 1. You also saw it in college algebra. Now, the problem is we're supposed to be drawing a right triangle. Well, if you look, by drawing in this diagonal line, we could draw a right triangle in quadrant 2 by dropping a perpendicular. We could draw a right triangle in quadrant 4 by dropping a perpendicular. Do you just have to choose eeny, meeny, miny, mo, which one? No, you have to use the other piece of information. The other piece of information says x is greater than or equal to 0. Well, what does it mean if you're greater than or equal to 0? Greater than 0 are what kind of numbers? Very good. Greater than 0 means the x's are positive numbers. So guys, which triangle would you draw where the x's are positive? Would it be quadrant 2 or would it be quadrant 4? Well, if x has got to be positive, it's got to be quadrant 4. So now you know, here's your perpendicular. And there is your theta. Now, we haven't done any trig yet. All right, realize that. We just talked 10 minutes and we've done no trigonometry. All we did is take all this information given to figure out how to draw the right triangle. Now, we're going to get the right triangle labeled before we can even do the trig. Now, you're going to say we have no numbers. Yes, you do. You know you moved over, you ran over to the right one. You know you went into the slope down 2. So you have your x value, you have your y value. Think about it. Slope is rise over run. It's the y's over the x's. So you had the y's and the x's. You need your r. Well, if I go over here, do I have a triplet that goes 1, 2? No, I don't. So I have to do Pythagorean theorem. So my x is 1 squared, my y is negative 2 squared, and that's going to equal r squared. What's 1 squared, y'all? 1. What's negative 2 squared? 4. What's 1 plus 4? 5. How do you get rid of an r squared? You give the square root. All right, guys, can you break down, simplify the square root of 5? No, you cannot, so you leave it square root of 5. I know in your calculator you could type it in, but you'll get a decimal that's irrational, goes on forever and ever. We don't want that. So your radius is square root of 5. Now, finally, we're ready to do trig. We're ready to define the 6 trig functions. So what are our definitions? Let's say them out loud. Sine is y over r. Square root of 2, no, I lied, negative 2 over square root of 5. Cosine is x over r, 1 over square root of 5. Tangent is y over x, negative 2 over 1. Cosecant is the reciprocal of sine. So that would be square root of 5 over negative 2. Secant is the reciprocal of cosine. So that would be square root of 5 over 1. Cotangent is the reciprocal of tangent. That would be 1 over negative 2. Everybody with me so far? That's the easy part. The trig is the easy part. But now look at your fractions. Are they all acceptable? Nope. Got a square root of 5 in the denominator. Got to have a whole number, so we'll rationalize. We'll multiply by square root of 5. So we'll get negative 2 square roots of 5 over 5. Square root of 5 times square root of 5 is square root of 25, but the square root of 25 is 5. Acceptable? Nope. Got to rationalize. 1 times square root of 5 is square root of 5. Square root of 5 times square root of 5 is 5. Now somebody's probably saying, Miss Black, can I divide this 5 with this 5? No, you cannot. They're not both whole numbers. That's a whole number 5, and that's a square root of 5, which is 2 point something. They're not the same. Can't divide them. Third fraction. Can't leave. Negative 2 over 1 is negative 2. The cosecant. Can't leave the negative in the denominator. It's got to float to the top. So negative square root of 5 over 2. Secant fraction. Can't leave a denominator of 1. Square root of 5. Cotangent fraction. Can't leave the negative in the denominator. Float it to the top. Negative 1/2. And there are the 6 trig function definitions. So, in this section, we have actually begun trigonometry. We understand there are 6 trig functions, 6 trig words. We understand we're going to memorize their definition as it relates to an acute angle, which is by the vertex point, and the 2 sides of the right triangle. Okay, in the next video, we'll talk more about this. See you then.